go to 3.2.3 in the ebook. I know you'll need a minute. And then in the problem 89, there should be a clickable link to get to the E tool.
All F majors, please stop by the Phoenix office for just a moment. All F majors, please stop by the Phoenix office for just a moment. Thank you.
3.2.3. So I'm trying to find wherever I left that tab. So, this is going to let us cheat the system a little bit because it's movable. It tells us the slope and it tells us the degrees. It was 45 when I opened it, but so we can use this to help us figure out the missing pieces of our trig table. So the one objective they want us to do is listed right here on our, look at the left bar where it says A, hint, B, hint. So your first objective, since we're missing 55 on our trig table, right, because my trig table, at least right now, has this much filled in. And then maybe we wrote 30 degrees somewhere. That was like 10 to 17. But we need 55. And then once we get 55, its reciprocal would be 35. Right? Its complement gets the reciprocal. So I want you guys to take some time and solve everything else on our trig table that we can using this. Now for 55, it suggests that we use a y of 8. So you're going to want to set your degrees to 55, but set your delta y to 8. And then, for those of you thinking, well, why isn't delta x shown? If we know the slope ratio, we can figure out delta x.
Slope equals 1.47. I got 1.42. I got 1.45. Desmos is wrong.
Well, no, aren't they all 1.4 something? Because, okay, I wasn't doing it because I was waiting for you guys. So 55 with a delta y of 8. Real close. So it's hard to get very precise. And actually, somewhere on here, it says all angle degrees are rounded. Yeah, sorry, I got distracted because I was trying to... So that angle is not exact, right? So that's where we're going to get a little discrepancy. No, I mean... So I got like 1.43. What'd you guys get? 1.42? So if we average, we'd be right about 1.44 or 1.45. Go ahead and write down whatever you would like. But that is, that's what goes in approximate slope ratio as fraction and decimal. So that's our decimal value. So if we wanted to make it nicer, we could make it like 14 over 10. If you wanted. Try to solve your 8 degrees, your 83 degrees, your 84 degrees. Try to use this E tool.
Can we work together on this?
Oh, sure you guys can.
I'll do the 8 degrees.
Okay, then I'll do 7 and 8.
Wait, it actually doesn't matter what y we use. The slope won't change.
Okay, for 83, the slope is 7.69. For 55, the slope is 36.6.
Okay.
Wait, for what?
Wait, are you sure?
We already did 55, Jake.
Because is that equivalent to 1.43?
1.44?
26 25ths?
36 over 25.
Did you say 36 over 25?
36 over 25?
Oh, 36. I thought you said 26. And I was like, wait a minute. That's going to be really close to 1.
Okay, wait, I got for 8, the slope is 0.13, so like 13/100. What did you get for, did you say you have something?
I did 83 and got 7.969.
7.69 is your slope?
Yeah.
So,
Jake can do 84.
Wait, I did 83 and I got 8.45.
Uh-oh. Let me do it. I'll do 83.
This is how mine looks.
Wait, but if I make my triangle
My
bigger,
Y is 10.
Yeah, so that might do something.
It shouldn't actually.
well, because remember, this is gonna round everything between
I got
82.5.
7.84.
Yeah, so guys, this is gonna round everything between 82.5 and 83.5, and call it 83. So we're gonna have a little bit of like loosey goosiness here. So it's not perfect. I think we probably need to start to try to like formalize the relationship. So we know 45 was 1. Right? We had that from the get-go. I want you guys to discuss for a few minutes. Is there a way we can talk about how the angles are changing? Hey, Jake, what you're doing is really distracting.
The difference in like the slope gets way bigger when like you start like getting closer to 90 degrees.
So could we formalize it with like some reference points of like 10 degrees, 20 degrees, 30 degrees, like I don't know, just what could we do to try to make this
we
better?
can make a table of like all the multiples of 10 to see like if there's like a really
Go ahead. Yeah, let's try to investigate some relationships. You guys can come to the board if you want. I'm gonna run the rest of them
Yeah, let's
quickly.
make a table.
Don't kill each other. I'm gonna run the rest of them.
Wait, I'm not gonna kill them.
Ooh, wait, multiples of 11?
Oh
And
yeah.
that's really close to 45.
That's like a fifth. Well, the first.
We know that that works because we know that 11
do.
degrees is a fifth and 22 degrees is 2 fifths.
Okay.
So that would make 44 degrees.
It's not 4/5.
Yeah, that's not the,
No, we can graph that.
no accurate.
So, no, I don't like you. Where is the like smart thing? What's that here? Okay. 11. Nope. Thank you. 11 degrees equals 1 fifth. 22 degrees equals 2 fifths. What's 33 degrees?
3 fifths.
It's not. Actually. Wait, we know what it is. Because we can take the reciprocal thing.
Charlotte.
And then it's 30. No, we don't know what 33 degrees is.
Can't we do the
We know what 3 fifths
the
is.
90?
We can figure out what 3 fifths is. But we can't figure out what 33 degrees is.
Why do we need to figure out 33?
Because we're
Because
trying to
we
make
make
it
multiplies
even.
by 11. Multiples by 11 because you suggested that.
Yeah, that's not gonna evenly work out to 90. Oh, but it'll work out to 90 or 89 or 88. It's close.
You silly goose. You listed 2 wrong numbers.
Nope, these are both correct numbers.
No, I meant you said 82 and then 88 or whatever you said.
I said 99 and then 89.
Those are both incorrect.
Silly goose, you're playing a video game in math class.
It's a math video game.
No,
It's got
not.
shapes.
Oh my goodness, you could call any game a math video game if you.
Yeah, everything is math. Mr. Hudson says so.
Some things allow you to learn math, and other things are just there.
Exactly. Both are math, and we're in math class. So we should all just play video
Nice
games.
catch.
Thank you.
Okay, let's just like get out a protractor. We could just use our calculator. Sine of 33 degrees.
Oh, yeah.
Let's make this easier
He
on
said that
ourselves.
we could use calculators.
Yeah. Just use sine 33.
0.9999118601.
I feel like you did that wrong.
Are you sure?
I just did sine 33.
I don't think we're supposed to. I don't think
Uh,
that's the way you do it.
Wait. Oh, that works. 0.99.
0.9999118601.
33 degrees.
Ooh, why is it so
You guys
9.
I know. I'm paying attention now.
No, you're not. You're multitasking.
9.
You
You're letting yourself put in half effort.
No. 'Cause
Wait,
45
33 degrees is 0.99?
Because he did sign
yeah.
and then
I did sign 33.
Wait, can you
But
do
that's
sine
not-
of 11?
I don't
That seems really wrong because 45 degrees is 1.
We're not right.
Yeah, that can't be right.
Here's the problem.
Sine 11 is negative 0.9.
You don't know how to use the sine, cosine, and tangent functions yet. Your calculator's worthless right now.
Oh, dang it. That's not what we could work.
So, Jake, you don't know what you're doing. I do have stuff to teach you. You need to keep yourself off of your games on your computer. You don't know this
Someone
yet.
get out a protractor.
Why do we need a
Because
protractor?
we need a measure 33 degrees angle.
I mean, can't you also use the E tool?
We could do that. Yeah, that's easier.
Is it still open here somewhere?
Yeah. 33 degrees, right? 0.65. It's a nice round number. Actually, we should change these to decimals so we can look at it
Okay.
nicely.
Just erase my.
Alright,
It's just a line. It
Slope
doesn't
is
Yeah,
matter.
but-
0.66 for 33 degrees.
Why is it so big?
Slope is 2/3 for 33 degrees.
2/3?
Yeah.
Ooh,
is it
if
a
you want
Let's
it,
just do 0.6.
So wait, is it a geometric function then?
I don't know.
Yes,
Why are
it
you
is.
asking
I'm
me?
just
We're trying to figure this out.
I'm just speculating.
Why is this line thicker than it used
So
Because-
Marcus,
No.
Dr. Satoy, right, just told us that trig turned geometry into numbers, right? It turned like sizes of things into numerical. So there's probably a function. Question is, what type of function?
It's
Okay.
definitely not arithmetic.
Yeah, it does not look linear.
Aaron,
You got a point there.
Can we like scroll down a bit?
Yeah, you can do anything you want.
Because we're getting
You
kind
silly.
of close
Oh
to
my
the
god, you got it.
Doesn't matter.
There. I fixed it.
44 degrees. Let's go back to the E tool.
I'm using Firefox these days.
Oh.
Yeah, Chrome's got some issues.
Oh, what's going on with Chrome?
Just a variety of things between Facebook and Google, and just apparently Firefox is
Facebook-
more secure. Than,
Facebook, Instagram, and something else stopped working.
MySpace.
Alright, slope equals 0.96 for 44 degrees, which is close to 1, which is good.
Yeah, that's what I'm getting.
That sounds right.
that seems more appropriate.
Yeah.
Okay, so what are we putting?
0.96. And then we-
That is kind of funky.
Just like you.
All of this entire.
All right, go ahead and put 45 as 1 because that's a nice one, and we know that one for sure. That's like a reference point.
Okay, reference point.
And then, do you want to start? Well, we can't really start at 90 because it's undefined. Where do you want to go from
There
there?
we go.
Let's just keep going by multiples of 11, like 10.
So you're going 55 next.
Yeah. I feel like we should have just done multiples of 10, but oh well.
Oh my god, why is that?
I mean, you could also.
Alright.
But we already started.
I thought we already did 55.
Oh yeah, we did. What did we get for 55, guys? It was like 1.4.
1.41.
Yeah.
1.41.
That's what I just got. Okay, 1.44 is what we had.
That. I feel like we should check that.
No, you're just a silly goose.
But if you got 1.41.
So it's obviously a geometric function. Why is he wearing a cape?
How is? Okay.
Why is he a black triangle?
So
His name is Delta.
So this one has a difference of between these two. There's a difference of what is that? It's
Triangle man.
All right, don't make me be the teacher that says we can't draw pictures.
Okay.
Yeah, let's do that. So wait, 0
between 44 and 55.
adding or multiplying?
Adding.
So what?
Oh, from 44 to 55. Yeah, he skipped over 45. Yeah.
This is a 1. And then 33 and 44, it's a difference of 30.
Wait, so this is.
So So is it over 0.3? Is that right? Is that how you calculate geometric functions?
No, wait, no, it's y. No, gosh, that's too big. Oh, that was so good though.
So if I calculate what you just wrote up there, 0.48 divided by 0.3 is 1.6 if you want that number.
Yeah, I don't know if we do though.
Alrighty.
Wait,
So, this is obviously a geometric sequence.
can you see if 0.3 over, can you calculate 0.3 over 0.26?
1.1538.
Oh, it's different. Then it's not a geometric
0.26
function.
divided by 0.2 is 1.3.
So, it's not a geometric function.
Yeah. It's
Hold
like,
up, that's confusing.
Wait, is it? It's 1.3 like exactly.
Yeah.
What was this one over this one?
1.6.
No, 0.48 over 0.3.
1.6.
Oh, it was 1.6, and then 0.3 over. That was like 1.9, right? 0.3 over 0.26.
1.15.
1.1. So it's just all over the place.
It's all over the place.
Yeah. Although it's less than 2
Thanks.
and over 1. We
Wow.
know that.
What helpful insight.
Maybe observe more of the table?
We could do that. Or we could just Google a table with all degree measures, and then it'd be
It's
much
not
easier.
though.
No, that's the geometric sequence.
Yeah, but it isn't.
I know, but Connor asked for.
Isn't there like square something thing mabobber where like you square x or something?
There's
I got
plenty of
that.
things where you square x.
Oh,
Scroll through.
I just did that. Oh my gosh. I'm so
I feel like we should get rid of this, like this not one, or move it. So wait, I'm gonna switch tools for a second. Because we might want to continue the table.
Right. Okay. Great. Okay.
Why are you making a demon baby?
No, I'm just drawing Delta Man in like.
I think he's
contrast.
mad that the math isn't coming out.
Stop!
I'm drawing Delta Guy in high contrast mode.
Would he be white though?
Yeah, whatever.
Get your hands off it!
The page is white, so I can't draw him white.
Oh, I can draw.
What? Hey, what's the ratio of an 89
Delta
degree
Man.
angle?
89. It's like 62 or something.
Because it's on our table, right? Like it
Yeah,
wants
I got
us to
like
figure it out.
62.
Oh, you tried it already?
I tried it on the tool.
What about 84 degrees? What was 84 degrees?
7 or 9.81 is what I got.
Wait, what did you get?
Okay, 84 degrees.
What did you get paid
That's
for?
not
I
quite.
got 9.81. Might not be right because the tool is. I'm blaming the tool. It's not my fault. It's the tool's fault.
So you would prefer like somebody to give you exact numbers?
Yes.
Yeah, like just Google.
9.64.
So you mean like if you had a different copy?
Oh my gosh! Thank you so much.
So like this might help us.
Yeah.
Loads.
The answer sheet.
Okay, so if I put that up on the screen for you guys.
Wait,
Wait, wait, wait.
don't do anything to the heel. Oh.
Wait, what's 2/3? If we should draw a line with a slope of 2/3. I feel like that would be. I feel in my bones that would be useful,
Oh, wait.
but maybe
No,
not.
ink on this?
Oh, you can. You just have to click the little gray thing on the side, and then you are writing on the screen, not in Smartboard. Or I can take a picture really quickly and throw this in Smartboard if you want. But you got to stop drawing demon babies because we only have 10 minutes left.
And also, it's recording, so like.
All right, function, print screen. My cursor is going to be on there, but whatever. You guys can get over it.
No, we can't. It's a deep travesty. Not tragedy, travesty. Two very different things.
And it didn't get the whole thing.
Awesome.
I can try again, but Well, yeah, because then I copied something else. You know how computers work. Well, it's still back here.
Yeah.
It's
It's just gonna be forever in the archives of Smartboard.
almost you have to-
All right, so
It looks weird.
we gotta think there's a reason that CPM gave us what they gave us,
Like, we could
right,
think
to work
that.
with.
Or it could be just like a random assortment of numbers because they're a math book and they needed like 20 numbers for it to be a full lesson.
Yeah, but why would it be random? Like mathematicians
Well,
aren't
it's not
normally.
random. Some have relationships.
Yeah.
But like
20, no, wait.
Like
So,
8 and
18 and 72 and 11 and 79. I guess, kind of. Wait, let me think. Yeah.
yeah. And then also 11 and 22.
11, oh, yeah.
But I don't know why they have a relationship. That one is confusing to me.
No.
Because like it multiplies cleanly by 2 basically. But,
Is anything else here like clean? I guess if we're gonna use that word.
68, the 72.
Oh, 79 to 84 is also a
79 to 84, I can't.
Okay, so 68 to 79 double in slope ratio, but they are nowhere close to doubling in size.
And then it also doubles again to 84.
Interesting.
I don't know if it's on that table. But it
Oh,
goes
yeah,
2.5 to 5 to 10.
79 times 84.
And they're slow. And their difference is 6 and then 12.
So that added 5 degrees and took the slope from 5 to 10. Like literally added 5 degrees. But then we add 5 degrees again.
It doesn't work.
And it goes crazy. Why does it not work? I don't like it.
So we saw yesterday from that video that sine and cosine are like the horizontal and the vertical, right? Circle moving around a circle, or not circle, not straight lines, whatever. Crap. All right. Well, even if we can't figure out anything good from here, now that you have that table, flip to the back of the paper, and or you guys can do this up here / if you want. Can we at least solve some stuff from some triangles that will maybe help us see some things? Maybe.
2.747. So that's just like 27.47.
13.737 over 5.
You guys do the math and I'll just write it down. Why is it purple?
Because you made it.
Because I made it purple.
Oh, okay. This is right, right? Right.
6/50ths. Hey Jake, what you're doing is not productive.
It's 3/25.
What does that match up with? 6/50ths. Or 50 over 6. What does 50 over 6 reduce to, right? Because if we're doing that angle at the bottom.
13.737 over 5, so multiply 13.737 by 2. And I don't think you get that.
50 over 6.
You don't get that.
Is 8 and a third.
Oh, that's 83 degrees. We have 50 over 6. It's 83 degrees.
For what?
Oh.
For theta, for B. Theta would be 83 degrees because we have that on the table.
Yeah. Jake, stop erasing my thing. I got it.
That's
Right.
wrong.
No, this is right for A.
Oh.
So according to our table, the slope ratio for a 70-degree angle, I'm going to pop this up again.
2.747.
Yeah, it's 2.747. So Connor just multiplied by 10 because that's what his run was. Right?
So
Here,
then for C it would be 84 degrees.
Okay, well, you don't.
Right?
so at least if we had a reference table, like we can do certain things. But yeah, so 10 over 1
Is 84 degrees.
goes to 84 degrees.
Also, so like when we're doing the state test, we'll have this, right? Or do we have
No, but you'll know how trig works by then. You'll have your calculator.
Over 0.141.
8 degrees is, ooh, yeah. So wait, how, if we have the rise and we want the run, what do we do?
Divide by the sign.
divide by the what?
Like the slope of the hypotenuse.
So divide by that 0.14.
Yeah.
I'm lost.
Oh, sorry.
Would you like to explain yourself?
So like,
Basically, to get it, so for this one, you multiply 10 by the slope of the hypotenuse, right? To get y.
yeah.
And the slope of the hypotenuse is the number on the right side of
Yep,
the chart.
yep.
And then so you just divide by that number.
The slope is always multiplying this direction. Right? So if we need to get this value, we have to go backwards, which is division. So if we do 20 divided by the slope of 0.141, we get 141.84 would be our base here. What about E?
I wonder, what could it be?
Okay, well, quit leaving me in suspense.
It's 0.
Oh, 0.
It's just a line. That's not even a triangle.
For an 89-degree relationship, we said that slope is like 57. So you got to multiply our 2 by 57.29.
So like 114 point
57.29.
8.
114.58.
Oh, 5. Dang it. I was 0.1 off.
I might have done that.
No, you probably did it right.
Yeah, it's 114.58.
Oh, I did something right. That makes me happy.
What about G?
That would be.
And I got it wrong.
Oh, that's not possible.
Not possible.
Also a lie. Wait.
It is also a lie.
Bye.
Oh no, I was in the middle of saying line, and I was like, no, it's just like that's what it is. It's just you can't really have a triangle with 2 90-degree angles. You can't
At
make
that
it.
point, it's a square.
So if you'd like to start your homework, you can. Tomorrow we come back to the Leaning Tower of Pisa.
Oh, yeah.
Pizza. Are you gonna tell us how trig works, or do we need to like learn it?
Oh, I'll tell you how trig works eventually.
Is it really complicated? And
Not at all.
Okay, because my mom said it was easy, and I was like, okay.
There are 2 trapdoors with trig. One is choosing the right function, because everyone memorizes this SOHCAHTOA phrase thing, and then they don't actually think. Like, I keep having to tell my 7th graders to open their eyes and turn on their brain.
Oh, that's what you used to tell us.
I remember in SOHCAHTOA thing. I don't
So-
remember what it was.
I remember Mr. Hall talking about
It was like
raising
sine, cosine, tangent. I don't
sine
remember
equals
why.
opposite over adjacent. Or no, sine equals opposite over hypotenuse.
See, this is why it's a trapdoor. Why do you have a microphone?
Oh,
That's because people wanted me to bring my.
I remember how.
And then equals opposite over adjacent. Boom.
Wait, did you
So-
say cosine also equals opposite over hypotenuse? I think it's
So wait, if we're remembering this SOHCAHTOA thing, and we've got this as our table, and this is our theta, what function do we think we're actually working to like develop here?
so sine?
Are we using hypotenuse?
No. Wait, yeah.
Opposite
We're using
over.
the slope.
It's opposite over adjacent, so it's tone.
It's tangent.
Ooh. So we think this is actually a tangent table?
Yeah, I think so.
Sure.
I think it is.
So you're saying there's some function that we don't know what it is, like geometric.
Looks like a slope triangle.
There's some function that we're hypothesizing is the tangent function
Yeah.
that is supposed to take an input,
A degree.
not necessarily a degree,
Isn't
and,
it?
and spit us out our slope ratio.
I've done this before.
I think we did this too.
You know what? I'm just gonna go get this.
Now the reason, sorry, this looks like inches, and really I just want it to be input. And really we should just say theta, right? The input's always theta.
Is it tangent equals opposite over adjacent, or is it tangent of opposite over
Can it also be like
Tangent
an equation?
of our input
which is opposite?
equals the slope ratio, which is rise over run, right?
So we're using a degree.
But we tried this in our calculator and it was broken.
No, we did sine. We didn't do tangent.
Either way, even if you try tangent right now, it's going to be broken.
But it's delta y over tangent delta y over delta x.
So we need to put in here how big the angle is. But degrees, I'm telling you, is not going to work when you go to type it in your calculator.
You have to use radii or something.
Radians.
There are other ways that we can talk about angle size.
It's there. I talked about it. Does my calculator understand that?
Well, we did make a couple reference points the other day, right? What did we say 2 pi was equal to?
No.
2 pi is circumference.
Oh, yeah.
2 pi. Yeah.
Wait, no.
No,
2 pi times the radius is the circumference. But the reason for that is 2 pi rotates all the way around.
Twice.
No, just once. 2 pi is one rotation. Pi is half a rotation, meaning 90 degrees is how much?
Pi over.
Half pi.
So this is pi over 2.
Wait.
Can we have
What?
trig?
Hold on. What would 45 be?
Pi over
Grab your calculator.
pi over
Grab your calculator. Hit tan. And then put pi divided by 4. Close your parentheses. You gotta close parentheses, otherwise it gets mad.
Where's the pi button?
It's next to the cherry button. Whipped cream. It's also there.
Shut up. Oh yeah, pi. Tangent of pi over 4.
Get you one.
Sorry.
That's
So the reason that our calculator was not doing anything worthwhile for us is our calculator once fed radians. It once fed some pi.
Oh, so radian is a division of. It's a fraction of pi, or including pi into pi.
We
Okay.
developed the idea of circumference and pi prior to formalizing degree measures, and then we made them all work together. But there are 2 ways to talk about angle sizes, right? The radians of the rotation of like how much it opens, and or the degrees in the quote-unquote corner, right, where the intersection happens. Tomorrow we will continue to formalize these ideas, and Friday you don't have math class.
Hey, no
Hey. All right, have a wonderful day, guys.
You
Favorite
too,
day.
bye.
Thank you.